Hello and welcome everyone. Today we're solving the question task scheduler. Let's get started. Given a characters array tasks representing tasks a CPU needs to do. So we are given tasks array, right? And these are the tasks that the CPU needs to complete, where each letter represents a different task. As we can see, that there is letters A, B, and C, or uh, as we continue reading, tasks could be done in any order, so we can complete them in any order. And each task is done in 1 unit of time. For each unit of time, the CPU could complete either one task or just be idle. Okay? And however, there is a non-negative integer n that represents the cooldown period between two same tasks. So if we ever need to complete um, two tasks at the same time, we need to wait like two like in order what I how I understood this process was like, okay, I have completed task labeled A, right? And I need to wait, say, n units of time in order to complete another task that is labeled A. Same with B or any other English letter that we are given in the tasks array. However, there's an yeah we have done and two same. Okay, this makes sense, right? And return the least number of units of times that the CPU will take to finish all the given tasks. So these are the tasks that we are given, and we have this example, and this is how they give us the example. So it took me a while to understand this problem, um, uh, and I had to watch different solutions in order to come up with an understanding. And first things first, finally, I can tell you that, say we are processing this tasks array, right? And the way we want to process this tasks array, we can do it in any order, right? We can do it in any order, no problem. So I think the optimal way to do it would be to process A first and then process B. Because when we process A, we have a wait time of 2 units, so we cannot process it in like in 2 units of time within that time. So after that, what I'm gonna do is uh, these are gonna represent the wait times of processing another task that is labeled, for example, A. So I have A, and let me process this A. So I'm gonna process it after 2 seconds, right? And I'm gonna put two pause times, and then I have this another A, which I'm also gonna put as an A. So and then after 2 units of time, I process this A, and then I want to process my B's, right? And I can continue the same way, but since I have these uh, like pauses, right? I can just insert one right here. So I can fill this one here. So it's going to be 1, 2. And after 2 seconds, I can insert another B, right? Um, and then I can, after 2 seconds again, I can just insert another B. So this is how they explain it here, which I saw at first was very confusing. But yeah, so looking into the example two, we can see the same thing. So thanks to LeetCode, I was able to understand this question, and I'm going to write the solution on my own now. So thanks, LeetCode. You are the best. So for this question, we want to use um, queue and a heap. So the way heap works, it's gonna and there are two types of heaps. There's a max heap and min heap, and by default, like Python provides us a min heap, but we can work our way around it to make it a max heap. So how it works? Um, we will have access to the smallest element in the min heap on top of the heap all the time. So, and it's gonna be constant time, anytime, just to get the smallest or the largest from the heap. So, this is the benefit of using heaps. So, and the way we want to use the heap is we want to have the maximum. Uh, we want to have the maximum number of occurrences of the character on top of the heap. And the reason we want to do that is because if we have the maximum number of occurrences of the character spread out in the our operations, like in the way we process them, we can fit in any like other labeled tasks in between. So say we have the tasks that we need to complete, such as A, B, C, D, A, say, and then A again. No, B, A, right? I mean, actually, it doesn't matter how we want to. So, say, I'm just going to say A, here. So, we want to complete these tasks, right? So, say, in a, like a random case, we can just say, okay, process B, and we have N of, say, 1, right? So, in this case, uh, what we want to do is we might say, okay, since there's a wait time of 1, we process B and we will process another B in, say, after 1 second, right? So we process this B and this B, right? And if we process it, and we can process C in between, right? And let's process B now, or A, and let's process another D, right? And then process A. But say if in this case n is 1, but what if we have an n in a, like a, say, greater number, and if we just spread a across, in this case we didn't end up, oh, we have another wait time and then a, right? So if we could spread the most frequent one uh, in our, say, tasks operation, like the way we process tasks, that would be much easier for us to fill it with the other labeled tasks. So we can say, okay, once you process A, there's a pause of 1, and then you can process another A, and then you pause, and then you process A, right? So in between we can just throw, and then what's the most frequent after, like once we processed A, we will not have access because we want to save it in the queue, and then when the right comes we want to add it back up uh, to the tasks array so that it's not available until the right time comes, right? So we've processed A, like say we have processed A, and we have added to our, like, queue, and when the right times comes we're gonna pop from the queue and add back to the heap, and each time we do that, right, we have processed, say, this B, and we put the wait time in a queue, and when that wait time comes we will put it back up to the heap. So I think it will make more sense as I will code it, but one thing to note here is that if the n is a negative number, this say, since we will not have like a negative time unit, I think it doesn't make sense for us to have it, and they clearly indicate that n is a non-negative. So if I was interviewing, I would make sure to ask that if they don't clarify it. And so yes, and the constraints are the tasks will be at least, will be at least one task to process, right? And I think we can just yeah, we will just be able to do that. And yes, this makes sense. And the integer n. So how it works when we have one task, right? We just take the task and we say, okay, we count the number of times that particular task occurs, and it says it only occurs once. We get the value from it, right? And like the occurrence value, and then we use that occurrence value to say we so I as I will code it, so the edge case would be, as I want to, let's say test case, right? So test case would be when there's only a with a wait time of say 7. All right. mm, so to get it started, as I said, we want to have the count of the occurrences. So it's the best way to do it is to have a count dictionary. In Python, we can use counter method, which will return us the number of occurrences um, of the tasks labeled in the tasks array. And then once we have access to that, we want to have a heap. So the way we are going to initiate our heap, so it's going to be max heap. So as I said, in Python, it's going to be min heap, but we can work our way around it. So my max heap is going to be uh, so uh, for each I say count, right? For each count in count dot values. So this is going to return the list of like the occurrences, and once I have these occurrences list, I want to put it negated so that we will like artificially like creating this max heap even if it's not like available in Python. So we want to negate it, and we want to put it into the max heap, and then we want to use the Python heapq.heapify function in order to turn our max heap into the heap. So heapq.heapify, this is going to um, turn this max heap into a heap. Um, yes. Once we have that, we want to have our while loop. So our while loop would be while we have the max heap, right? Or the queue. So we need to have access to the queue, which I'm going to indicate as the queue, which will be the double-ended queue. Uh, so we'll have the queue, assign it to the queue. So while we have the queue, um, and I want to have to count the time that's gonna take, so I'm gonna indicate it as 0. So each time I process, I want to put time plus equals 1, right? And I might say if there is a max heap, right? If there is a max heap, what I want to do is I want to pop from the max heap, uh, and I think the way it works is heap q dot heap pop. We pass in the max heap, right? So this is going to pop us the like the the most occurring available task, and we want to say and this is just gonna return us the number, and I want to like increment it by 1, so that 1 plus this number, right? Meaning I just process this number, and once I process this number, so I would say um, task, right? If once I get this task, I want to say um, I got this task, and there's something else that I want to do. I got the task, and let's say 3, right? And then I want to, like, -3 in our case, and I want to increment it by 1, which will become 2, uh, and I want to put back this task, right, into the queue. So I would say queue dot append uh, task. So I think I'm gonna do it like this. So when I like I said, so I would say task. I'm appending the task, and I want to append to my queue the task and the time that I want to add it back uh, to the heap. So task, and it's going to be whatever the n plus the time. So whatever is the time, right? Time whenever is it. So next time I will process this kind of task, like this label task. It's going to be when this time comes, right? And I think while popping, I should say, so when I pop, I get uh, the task, right? So I think the only, and I should make it clear that I only need this task. So it should be the first one in the set. Say if it's, well, a bunch of A's, and say we had the wait time of 7, right? And I might say if there is a queue, right? If there is a queue, and if there is a queue, and the top of the queue, which will be, say, queue, the last one in the queue, which will give us the uh, like, do I need the? Oh, I think I since this is the So I think the first one in the queue, right? So the first one in the queue and its second value. So if this is the time which is equal to the time that I want, in this case, I want to pop from the queue. So it's going to be queue dot pop left, and this is going to be again the tasks that I want. Uh, to add back to the max heap. So I would say heap queue dot heap push to the max heap, and the second value would be queue dot pop left. And once I do that, I also want to make sure to return the time that it took for the entire thing to execute. But I think there's something that I'm missing, because while there's max heap or the queue, right, and I'm incrementing time each time I process it, but say when this becomes 0, right, if there's a max heap and task is equal to 1 plus heap queued on heap pop. So the only time I want to say, uh, but if the say, so I think the only time I want to append to the queue is when, if the task, yeah, if there's a task, right, then I want to append to the queue. Otherwise, I don't want to append it there, because say if it became like we had a which was a wait time of 7, right, and then I was like, okay, I said time plus equals 1. I added the time, and if there's a max heap, so in my max heap I just have one task. Oh wait, yeah, I'm popping from my max heap, right? Since I have already heapified it, so I get the task, and then if this is the task, I append to my queue. So queue dot append task n plus time with the right time, right? So next time I process A is gonna be uh, the say when time is equal the to 7. Say, yeah, when the time is equal to 7. And I would say if when this is going to be executed, I would say in the time when it's 7, um, I'm gonna push back to the uh, heap q dot heap push max heap. Yeah, so I am pushing it to the. But wait, yeah, wait. Since the occurrence of a is 1, like -1 here, I would just add it to the. So I will not end up adding it to my queue at all because it's going to be -1 and 1 plus -1. Yeah, so I think this case would work. So yeah, and to review it quickly, we would say we're counting the tasks, the occurrences of the tasks by their label. We're initiating a max heap by negating all the uh, count values, right? Occurrences in the count dot values. This is going to return an array, and for each one of them, we are negating them and putting into a max heap array, and then we are using heapq.heapify Python uh, in order to uh, make this a max heap, and then we are uh, using a queue, double-ended queue, uh, to store our wait times. So we have the time is equal to 0 and while max heap or the queue, right? Because we want to make sure that we process all of them. So time plus equals 1, and if the each time we process something, we want to increment our time by 1. And if there's a max heap, I want to get a task, which will be the first one in my uh, yeah, from the top of my heap, right? And then if there's a task, I would append it to my queue, right? If there is anything left, I'll just append it there. So q dot append task n plus time. And if there is a, say, queue, I would end the uh, last one. I think this is how you get it. The first one in the queue and the second one, like second element in the first, is equal to that time that we are interested in. We want to push it to the um, heap back again. So I think this is the way how it works. And the time complexity of this algorithm would be, so we are in the worst case, uh, so I think we are traversing this tasks array, and since we are um, like traversing it multiple times and making a heap out of it, I think it's going to be n log n. Yep. Let me try running my algorithm. Oh, I think I made a mistake here. So day Q. Yeah, so task would be equal to 1 plus heap q dot heap bob max heap. Oh, I think, uh, yeah, when we pop it, I think I don't need this. We can just say max heap, right? I assume this is how it works. Object has no attribute heap pop. Okay, I think heap q dot maximum. So when I pop it from the max heap, right? And then I want to get the first one. I don't know how why it's not working. So it's not subscriptable. So when we pop from the max heap, right, we get this. Now, I only care about the first one, right? Uh, Not sure. This is not working. Let me see. Let me see. Oh, I see. So the way it works is that we actually don't care about the uh, when we're putting back to. We actually don't care about the time, right? But how if yeah we care about the time. We only when we add it to the queue. That's why we're using the queue. So yeah, and here I think yeah this is how it works. Oh, because in our max heap, wait, in our max heap, I think in our max heap, we actually don't care um, left, and I think we just need to append the first one here, and yeah, yeah, we don't need this. Let's try submitting it. Yep. Thanks for LeetCode for the amazing solution. Um, yeah, I think it's a very interesting question with these very intricate details. So I think I learned something. Bye.